Right, so now we're going to just finish our step 3 and we're going to talk further on how to go about it. So step 3, what are we going to do? We're going to sort our existing sorted list. This first time we sorted it based on candle body size, and on the second time we're going to sort it based on our wick size. Wick length or wick size. So the first sort, we're going to conduct 2 sortings in step 3. The first sort is going to be 3.1, wherein we sort the top wick. The next sort is going to be 3.2, that is the bottom wick, right? And that's it. That's your algorithm. So congratulations, you have a sizing chart for your stock pattern, your stock or your chart. Okay. Now this is our fundamental object of study. Congratulations, now you have made your object of study, and now we're going to talk about how we actually study something. Right. So areas of interest are the following. So let's address the ambiguity. When we have something that looks like, say, like this, it has decent top and bottom length. However, in our set, we've seen that this same candle size can go really crazy, and the same candle size can be really small. Okay, so the point is that if I had something that looks like this, I don't have a actual way to decide which one I'm going to go to, right? Is this either option 1 or option 2? So the answer is to take something in view. The reason is because if I make the act of going from here to here or from here to here, I lose the information that makes these two fundamentally different or these two fundamentally different. And so inadvertently I'm establishing some sort of equivalence between them, which I do not want to actually establish. Because when, say, in the future I have something that does look like this candlestick in question, then I'm not going to be able to predict it because it's going to either give me a false positive that looks like this, or it's going to give me a false positive that looks like this, depending on which one I round it off. So that's an issue. And so instead of trying to decide which one to round it off to, we're going to take something in between. Now, how do we do that? We do that by defining a fluctuation space. Right, so fluctuation space was defined to address ambiguity in wick lengths. So we make use of our wick group 1, wick 2, wick 3, and wick group 4. So here, let's just assign this as 1, 2, 3, 4. And what I basically want to do is I want to have some sort of space, preferably some sort of unit square, where this is 1, this is 2. Oh no, I'm numbering them wrong. So let's just scratch that because it's laggy when I try to erase. This one, this one, this one, and this one, they all represent points, and we want to talk about how they are close to each other, right? How something is almost 1 or almost 2. We want to be able to assign that sort of idea or motion to each of our stock points. So this one would be 1, this is 2, this one is 3, And so basically, all of my stick patterns are supposed to lie in this space. That's the idea. And what I want to do is say I have one stick pattern over here, then I have one stick pattern over here, one stick pattern over here, one stick pattern over here, like this, and so on and so forth. I want to study this curve. So curves are well studied, and we can basically use all of our tools from math to ask things like self-intersection, sensitivity, particularly to initial conditions. Does the if I start at a point similarly over here and I go on, do I get a completely different graph that concludes like this? Right? So we want to verify that we can have multiple different points. We want to ask statements and questions that relate to sensitivity and self-intersection. And so another approach, over here I have taken the same 1, 2, 3, 4 points as these points, right? So the other approach, which is very similar. So the next approach is bounded path. Instead of taking 1, 2, 3, and 4 as points on a plane, as point on some space, I am going to define some plane like this. It's going to be R2 plane. And I am going to do the following. I'm going to put my initial point at the origin, and I'm going to define 4 directions. 4 possible directions for this thing. We assign this one for the first one, we assign this one for 2, we assign this one for 3, and we assign this one for 4. Okay? And now basically I have a point, and over time I'm going to either go to 1 or 2, or I'm going to go to 3, or I'm going to go to 3 again, or I'm going to go to 3 again, or I'm going to go to 4. You're understanding, right? So this sort of path, right? And basically I'm going to have some sequence formed by these 4 digits, and I'm going to interpret this as some sort of movement through art. Another thing to interpret this as is that if I have a point that has basically 4 directions to movement, then in some sense, even though these two are opposites of each other, I can consider this as 1 degree of freedom, 1 degree of freedom. Similarly, this is our second degree of freedom. And using these, we can form our basis vectors v1, v2, which is our basis vectors of our moduli space of the, let's call this the ball. Okay. This is another interesting direction to take it down. This introduction is basically a very small explanation of what is the objective and what are the basics. And it's completely natural if nothing is entirely clear. So I encourage you to reach out and sign up for this project. Thank you.